And to let you know, my name is Daniel Jacques. I am the Stockroom and Safety Manager. I use he, him pronouns. My job is quite extensive for the department. I help keep you safe, that's part of the title, by engaging the concepts and topics of safety. I'm also in charge of all the chemicals and experiments that go into a room to make sure everything works as it goes in. Once it's here, it's your job to make it work. So, we're here to help you with that process. You'll be working with your professor very closely and your LIs who will also be assisting you through this process. But it's really important as you go through a laboratory to think about the topics of safety. Because as the American Chemical Society says, good science is safe science, and safe science is good science. Because ultimately, the choices you make in a laboratory can affect your health and other people's health who are standing around you. It's also an issue of environmental sustainability because spills and other such things can damage our environment and the air and our water. Throwing chemicals down the sink that don't belong can damage our water supply, or chemicals going into the wrong trash system can damage our groundwater because of it going into a landfill. So all of those things are tied up in the concepts of safety. It's not just one's health, although that's a huge part of it. This is not a high school chemistry course. We will be using chemicals that are potentially hazardous and dangerous if you don't use them as you intended, as is intended, and as directed by your professor and the experiment. So it is very important to make sure that as you have questions, when you're not sure about things, that you ask your professor for help or you ask your LIs. We don't expect you to know everything. That's why you're here. If you knew everything, you would be wasting your money being here. So it's okay and really encouraged to ask all the questions you have. I know in college we're just so afraid of looking stupid that we don't do things because, we're supposed to be scientists and we know everything. That's why we're at Geneseo. And you are a really intelligent folk. I know that you're here. But part of being intelligent, part of engaging your intelligence is asking those foundational questions to make those connections, to be able to engage these spaces better, more safely, and have a more positive experimental experience. So today, I'm going to be talking about some rules. I'm going to focus mostly on rules and not the applications of them because there isn't a lot of context. This might be your first lab, or you might have had some biology labs or other labs last semester if you're a first-year student. But in a chemistry lab, this is our foundational experience. So this is really going to be pretty contextless, especially since I know that a lot of folks, because of COVID, didn't actually have a high school laboratory experience. We know that. We're familiar with that now. And it's important for you, especially if that was your experience, to not have a laboratory experience, to really engage these laboratories via asking good questions and making sure you're prepared before you show up. The last thing that you want to do is read the experiment 5 minutes before class starts or as you're trying to do the experiment. That's a really good way to not actually get the results you're looking for because you're trying to figure it out as you go. It's kind of like cooking. If you're trying to figure it out, you miss a step or a step takes too long and that souffle falls flat. Chemistry is a lot like cooking. Using a laboratory is a lot like using a kitchen. As you get to know this laboratory better, it's going to become a lot smoother. It's going to make more sense. But you could be a really good cook and be in your brand new kitchen and everything is like weird because you're not used to that space. But it's also important to never ever become complacent in this space. Kind of like that kitchen again, because you're sharing that space with a whole bunch of different chefs. And if somebody leaves on the stove and you didn't realize it was on high, or somebody doesn't close the fridge, or somebody puts something where it doesn't belong and you bump into it in a kitchen. Those hazards are all the more magnified in a laboratory space. And so it is important to think about how you are working around your lab partner and all the other people in this space at all times, because this laboratory is always a potentially hazardous space. So, if you have any questions as I'm talking, please feel free to interrupt me, because I'm doing this without notes. I don't need to follow any notes, and so I can be totally interrupted and answer any questions more thoroughly that I didn't answer well. I should be answering every single question on the student safety questions. If I miss something, please let me know. If you need clarifications, please let me know. I'm going to be asking questions at the end to make sure I answered to your satisfaction on all of these. These are graded, so it is important to make sure that you do answer as thoroughly as possible based on what I'm talking about as we go along. So, before we get started, are there any questions? Okay, so let's get started from the very beginning. So when you walk into a laboratory space, this is a professional laboratory space, and you do need to be wearing your professional gear, because welcome to nerddom. This is what we do when we come to these spaces. We have to wear our PPE. What does PPE stand for? For those of you who watch the video, what does PPE stand for? Yes. Personal protective equipment, absolutely. And you're going to need 4 pieces of personal protective equipment for sure. The 5th one is voluntary, but I strongly recommend it. So let's talk about each of those pieces. What would be one of those pieces that you have to wear when you come into class? Yes, the lab coat. The lab coat is very important. You will need one every single time you come to class. If you forget one, the stockroom will be able to spot you for that, but we're charging $5 for the disposables. They now cost me $17 because of COVID. And so please go buy one, invest in one, and you'll use it for this semester, all your other chemistry courses, and other laboratories that you use at the college. If you don't do other laboratories, it's a great Halloween costume. But in this lab, you do need to button it up because it otherwise is a costume. You want it to protect you. All right. What else do you need? You have your lab coat. You also need, yes, goggles, safety goggles. And I'm going to circle back to safety goggles in a minute because they're safety goggles and not safety glasses. We'll come back to that in a moment. Okay, so lab coat and goggles. What else? Yes. Closed-toed shoes. That's very important, and so I'm going to be very specific about that. They need to be fully closed-toed shoes. You do not and cannot wear Crocs, ballerina shoes, flats that have the top of the feet open, high-heeled shoes, sandals, thongs, any of those kinds of things because of 2 reasons. 1, gravity check. When things fall and break and splash, they splash across feet, right? Broken glass is very dangerous for anybody when they're not wearing the right foot gear. And if we need to evacuate this lab, you cannot evacuate quickly if you're wearing other types of footwear. So closed-toed shoes are a must. All right, so goggles, lab coat, closed-toed shoes. What else is required? One more thing is required. Yes? Clothing that covers your legs, which means that it's really important to also, again, that splash issue, right, for your legs. If it gets on your skin, it might burn you. We got to wash it off, and so it's really important to make sure that you have that layer of protection. So I don't say pants because there might be religious exemptions or there might be health exemptions for reasons for not wearing pants. But we do want you to wear clothing that completely covers your leg, and that includes long socks. So this is the real big kicker, because I am a sock monster. If you're wearing invisible socks or low socks and your ankles are showing, your allies can talk to you about that, because I can see through these cabinets, then it's not protecting you. If you're sitting at the desk and you know how your clothing hikes up when you're sitting at at the chairs and somebody behind you is doing an experiment and your ankles are showing, you're still not protected. So you really want the long socks. Now, I don't ever want you to do this. Please never ever sit on these countertops. It's really important not to do that. But I'm going to stand up here for two reasons. One, for the video, and two, so you can see me because I'm short. So, really quick, the best way to not have a talking to by me is to put your socks over your pants. Just like that. One, that protects your ankles really well. And I also won't come looking really closely because I see your socks nice and up and safe for you, for the experience. Just don't forget to pull them down when you leave the lab because otherwise everybody knows you were in lab. But they're going to know that anyway because of goggle face, because that's the nature of strapping those goggles to your face. All right? Please don't test the process because it's just a safety issue to not be wearing the right PPE. So the things that are required are the lab coat, goggles, closed-toed shoes, and clothing that completely covers your leg. So that means no ripped clothing. And if you do have the ripped clothes because, you know, that's in style, then make sure that you have some tights or something underneath that. I recommend loose clothing because tight clothing isn't really protecting you, right? Because things just go right through. I'm not going to police that, but it's just not recommended. Additionally, as you move through laboratories, and even in this class, it's not recommended to wear poly clothing, you know, so synthetic fibers, because a lot of synthetic fibers just dissolve in the, you know, when they get hit by certain chemicals. So cotton is great, but again, I'm not going to police that because I'm not going to be checking tags. Also, midriffs and other such things, please don't do that because yes, your lab coat is one layer. You want more layers because this is exactly where you lean. And so that's really important. Any questions about those 4 required pieces? All right, so the piece that we strongly recommend are gloves, disposable gloves. Now, if you'd like to wear the nitriles or latex, either is fine as long as you're not allergic to either. If you find that you have an allergy to latex, then nitrile might be better, but you can also have, some people do have allergies to nitrile. And so if that's the case, let me or your professor know, and we'll be happy to offer you alternatives in terms of things that you could buy. Don't buy gloves from the bookstore. This is on video, and you're going to hear me tell you that, because they're really expensive there. Don't buy them from me if you forget them and decide you need them because you're going to be using acid that day, because they're really expensive because I'm not supposed to compete with the bookstore. So go to a big box store or go to Amazon, big box store, and buy a box of 100 gloves for like $7, right? Because I believe it's $7 or $8 at the bookstore for 5 pair. Don't do that. They're fleecing you. And I'm also expensive because I'm not supposed to compete with them. So just go buy a big box. And then you can share with your lab partner, and that's great. Because you will be using strong acids and strong bases and other chemicals that are potentially hazardous. Some of them may be potentially carcinogenic. And so it is really important to protect yourself. And wearing gloves is certainly one of the ways to do that. So I'll be circling back to gloves in a moment as well. But, again, lab coat, goggles, closed-toed shoes, clothing that completely covers your leg, required, recommended, or gloves. So I said I was going to talk about goggles. And so there is a difference between goggles and safety glasses. And there are a lot of different options, and so it's really important to make sure that you have the right options for this course. So these are safety glasses, and these are examples of what biology might allow, but are not allowed in this course. Because if I were to put this on, and then there were an explosion or a big splash, it goes up, comes down, and still hits me in the eyes, and I might have some damaged eyes. So it's really important not to wear these kinds of things in this course. So I already see some good ones around. And you want goggles that look like this. So they need 3 properties to be appropriate. These would be okay too, because it has all 3 properties. So the first property is that it should touch my face all the way around. So it should touch my face all the way around, 360-degree protection. You do want to strap it to your face tight enough that it actually closes around the edges. So if you have a thinner face, make sure it does fit. Because if you have gaps back here that you can stick your fingers in, it isn't protecting you. Additionally, you want to make sure that it is indirectly vented. So I picked these ones up because it's both good and bad at the same time. So these vents up here are indirect vents. If you have them in front of you, you can take a look. Air has to go around some weird bends before it goes into the airspace inside. But these have the indirect vents on top, but somebody took them out on the bottom, and they are no longer helpful. So make sure that yours do have vents. If you lose a vent, I actually have lots of extras. I'll be happy to hand you vents to put back in. All right, they're really important. I know people want to take them out because they fog up on your face, but then they're not protecting you. Additionally, you're going to need to make sure that they are chemically splash resistant. And that's harder to know unless you look at the packaging, but they should be basically ANSI, ANSI Z87 2003 compliant. That's a lot, ANSI 2003 Z87. So if you buy them online to buy nicer goggles like these are the UVEX Stealth, UVEX. I'm not a paid promoter, I promise. These are the UVEX Stealth. I've been using these for about 20 years. I like these a lot because they fit over my glasses. They have a nice soft edge so they don't leave that harsh line on my face after wearing them for hours, and they don't fog up nearly as easily. But these are what's appropriate. These are what's appropriate as long as they have all the tabs. And there are other kinds that are indirectly vented that are also appropriate. They often are found in green. Now, a couple things about these. There are goggles that look very similar, but they're also not appropriate. These are carpenter's goggles. Notice how there are vents directly drilled into the side. They just breathe, but they will not protect you in an explosion. So they look very similar, but they're not the same. These are not allowed in this course because these are directly vented. They're not chemically splash resistant. If you find that your goggles are fogging up, that happens. You might be a copious sweater, it might be a rough day. So if that happens, please don't take your goggles off while you're in lab, while people are working all around you, and try to wipe them off in lab because they're not protecting you while you have them down. So if you need to, leave the room, wipe them down, and come on back. If you find that it's a constant problem, come talk to me in the stockroom. I have lots of anti-fog material. It's just a bit of a challenge because the anti-fog material is alcohol-based. I can't put it on right away without burning your eyes. So come on to me at the end of lab. I'll pour it on. I'll have you, then you store it. It will dry, and then it will work a bit better. But layers of it work, so just keep doing that until it gets better. It usually takes about 3 or 4 tries. You can also buy that online if you want. All right. So, but just don't take them off while you're in class. It's not safe. Are there any questions about the difference between safety glasses and safety goggles? Okay, so let's talk a little bit more about gloves. So for gloves, again, we talked about the different types that are available that are useful, but gloves are not magical force shields. They are just thin layers of plastic, basically. Nitrile and latex are types of plastic, and they don't last forever. And if you get chemicals on them, well, chemicals can move through them over a period of time, and you're cross-contaminating everything you touch. And so what they're meant for is just that layer protection. Oh, I got a chemical on me. I'm going to take them off I'm going to throw them away into a lab trash, not a landfill, because we don't want contaminated gloves going into our water supply, right? And then I'm going to put on a new pair. That's how gloves are used, and that's why it's important to buy a big box of them and not just a couple of pair, because you might go through a lot when you're using them. So it is really important to make sure that you're not wearing the same pair of gloves all lab period because of that cross-contamination. And gloves have a shelf life on your hands. The heat of your hands, the sweat on your hands, and the oils in your hands, not to mention the chemicals that they might be exposed to, only offer your gloves a shelf life of wearing them of about 20 minutes before they start getting those microfractures in them and they're not really helpful anymore. And that's if you're just twiddling your thumbs. But nobody's that kind of lab partner, right? You're all going to be working on things. And so you should be changing your gloves relatively often anyway. And it circles back to reading your experimental protocol before you come to class. That way you know you might have wanted to bring gloves for that experiment because that experiment is going to be using a strong acid or a strong base or a chemical that might be hazardous that's talked about in your experiment. That way you don't have to come to the stockroom and go, oh, I need some gloves, and then be charged the fee for those. Okay. So it's also really important to know where the different types of trash in this room are. There are 4 different types of waste that we use in this lab room. I've talked about 2 of them already, kind of briefly mentioned them. What is one waste that is in this room? What is one of the 4? Yeah. The chemical waste, that's the most important one. The hazardous chemical waste we have in both rooms. So the other room is symmetrical to this one, so I'm talking about any facilities in this room. I'm actually talking about that room as well. It's just a mirror image. So the hazardous chemical waste will have your LI's name on it. It's in the chemical waste hood, and it looks like this. They will be working with you on when to use it and how to use it to make sure appropriate things are put into here and that it's appropriately documented so that they can then document it when it's time to get rid of it via environmental health and safety. So hazardous chemical waste is definitely very important, one of the most important things that we have to ensure that hazardous chemicals do not end up willy-nilly in our environment. All right, so that's one waste. What's another waste that's in this room? What's another waste that's in this room? We talked about, yes. Yeah, we have a glass trash as well. So glass trash in both rooms is also by the chemical hood. It's a paper box, looks like this. And this is where all your glass trash goes, either broken or not broken, like vials and other such things. All that goes in here. We never want our glass to go into a landfill trash. It's really important not to do that because we don't want broken glass to cut our custodial staff who are emptying that trash. That's a hospital visit if they cut themselves in chemically contaminated glass. It's not safe. Additionally, it goes into our water supply via groundwater in a landfill. Also not sustainable or safe. So it's really important to put all glass into a glass trash. If it's a vial, you don't throw the vial and the chemical into the glass trash. You'll empty the chemical out into the hazardous waste, document that according to the way your LI wants you to, and then that vial will go into the glass trash. If it's broken, we keep a brush and dustbin right over here by the side doors, and you'll use that. You'll talk to your professor and your LI if you break something, because it's really important that you let them know. And then we throw it away where it belongs, into the glass trash. What's another type of waste in this room? We have the haz waste, we have the glass trash. Yeah. The lab trash. The lab trash is for all of your chemically contaminated waste, but not the chemicals themselves. So a lab trash looks like this. It's the red bucket in both rooms. And this is where all the paper towels that you use to clean up your stations, your filter paper, your weighing paper, your gloves, All of these go into a lab trash because it's not taken to a landfill. It's treated like hazardous waste in the long run. It's really important that all gloves go in here, even if you didn't use them, because we have a saying in chemistry, hot glass looks like cold glass, just like clean gloves look like dirty gloves. We don't know, and so it's best to just put them in here. Please don't put your gloves into a landfill, clean or not. Okay? Also, don't scrape chemicals into there. So again, chemicals get scraped off that filter paper into the hazardous waste, however your ally wants to document that, and then that filter paper itself goes into the lab trash. Okay, so then what's the last waste? Keep talking about it for that sustainability stuff. That is the landfill. That is the landfill. All right. So nothing related to the lab should go into the landfill trash other than papers that are written on. Nothing should go in there. The only other thing that will go in there is food if I find it at your desks. We'll talk about that in a second. All right. So we have the hazardous waste, we have the glass trash, we have the lab trash, and we have the landfill trash. It is really important to put things where they belong for both sustainability and the health and safety of everyone in this room and beyond this room. It's also really important to also think about cleanliness when you're in this room. So I see a lot of people with their bare hands leaning on and touching these tables. I see some spots that have started to form because of experiments that started yesterday already. What are those spots made out of? Yeah, if you don't know, it could be hazardous. It could be hazardous. So you always want to get into the habit, starting today, once you go back to your stations and once we're done with this safety lecture, you'll want to grab some paper towels at the sinks. Again, same in the other room. Grab some soap that's at the sinks, and you'll wipe your station down. You'll clean it off, and then you put all those paper towels into the into the lab trash where it belongs. Because it's kind of like sharing this room with a roommate. So who's the clean one in your res hall? Is it you or is it your roommate? You know who it is, right? Now imagine this room is shared with 8 other sections. So you have 8 other roommates you've never met. Who's the clean one? And if you don't wipe down the station before you start and before you leave, then you are exposed to everything they did without even knowing what it was. Because on Monday, this course is Chem 209, which is our intermediate chemistry. They're doing completely different experiments. You have no idea what's going on because they're Monday afternoon, and this class happens to be Tuesday morning. So it is very important to start wiping down your stations and making that part of your routine. It's also important to engage the space very safely. And to engage the space safely means to also not have extra tripping hazards or other hazards in the room that don't really belong. These chairs, I hate them. They really shouldn't belong because people trip over the wheels all the time and they just get in the way as people are trying to navigate around this kitchen of a lab. And so if you grab your bag and you put it down here, then that's just yet another tripping hazard. And so all of your personal items should go in the cubbies. And the only things that should go to your desk after you've wiped and dried down your desk station are anything related to the lab that day and the writing implements. So your calculators, your notebooks, those kinds of things. But don't expose the things you don't need, because otherwise the potential cross-contamination has you take that home to share with your roommate. And yeah, I know you might want to kill your roommate, but don't do it that way or anyway. And you certainly don't want to hurt your pets or other such things because you just brought some chemicals home by accident. It's also important to think about the fact that, again, these things are, no matter how much you clean, it's never going to be clean. So food and drink must not be eaten ever in this room, ever. Gum is not allowed in this room because research shows you touch your face a lot if you choose gum. So it's really important that any food that you have, hide in the cubbies. I don't want to see it. It should never be at the station. If I ever see it at the station, I will take it and throw it away, and you won't get it back. I don't care if it's in a really nice, $40 coffee mug that you bought. It's trash. So it's really important not to take the last swig of something when you walk in the room. Do that outside. If you need to grab something to eat because you have a low blood sugar moment, it's early in the morning, right? Wash your hands, even if you're wearing gloves. Remember, they're not magic. Things can go through. Wash your hands, take it outside, and eat outside, and then come back in. Food or drink are not allowed in here. It's also really important to make sure that you tie your hair back. If you happen to have any hair that's long enough, regardless of gender identity, long enough to be tied back, because you don't want your chemicals in your hair as you're leaning over it. We will be using chemicals like sodium hydroxide. Sodium hydroxide is the active ingredient of Nair. Nair is hair remover. And the molarity, I'll ask this in organic when you get to organic, but the molarity, which might mean nothing to you right now, of Nair is 2 molar sodium hydroxide. And it takes 15 minutes for that molarity to dissolve your hair. Any longer than that, your skin starts to burn, right? Because hair is keratin, and your skin is a type of keratin as well. It's just a chiral thing. And it has then started to dissolve your skin enough to start activating nerve cells at 2 molar concentration, which is very low. We'll be using concentrations as high as 6 molar in this course, which is 3 times more concentrated. So you want to tie your hair back so that it doesn't get anything like that, let alone other things. And that's another reason why you want to wear your goggles, because you can imagine what that would do to your eyes. Are there any questions at this point? Because I've been hopping through things. Okay, so if we have an emergency, because they do happen, this is a real science building, and things happen, right? Sometimes they're drills, just like in the res halls. Sometimes they're emergencies, just like in the res halls. And so we never know. I have no idea when it's going to be a drill. So we always have to assume it's a real thing. Remember, there's a linear accelerator in the basement for physics. How many of you knew that? We actually have a linear accelerator. A couple of you knew that? Some of you didn't? There's a linear accelerator down there. Minus all the other active laboratories that are in this building across 4 different disciplines. So bad things could happen where we would need to leave this building. So if that happens, an alarm will go off. And when an alarm goes off, I'd like you to do these things in this order. So I want you to write it down in this order. The first thing that you want to do when an alarm goes off is turn off anything that is on that is heating. So if you have a hot plate that's on, you want to turn it off because we do not want to come back to a lab fire. But that's the only thing that you would have to turn off. It's just a hot plate. Once you do that, you want to then just exit the room. It is winter, so grab a coat because they're right next to the doors as you're going out, which is great because we're going to be outside for a bit, and a lab coat will not cut it. I mean, it's a California winter this year, but it's still going to be cold. I know that because I moved here from San Francisco. I was raised in Nevada. I still don't understand New York cold after all these years, but it's cold enough. Grab that coat. You then want to go down the nearest unobstructed stairwell. Now, I say unobstructed stairwell because if that stairwell is obstructed by other people or by the emergency itself, you don't want to go down that way. Got to be explicit about that. And so there are many stairwells in this building in case our closest one, which is right here next to the door, is obstructed. So in this building, of course, we again have the one right here. We have the one just on the way with the big brachiosaur in it, and that brick. We have one on the other side, over there on the south side. We then have one between the 2 offices of biology and chemistry. We have the main atrium stairwell, and of course we have the stairwell way at the other end of the ISC. You want to go down the nearest unobstructed one. Once you go down the nearest unobstructed stairwell, I do have to say, because I've seen it over and over and over again, you have to leave the building. Don't just wander on the first floor. People do that. Leave the building however you got out of the building. And then however you leave the building, no matter which way you went, so you might have to go the long way around, we have a designated meeting spot for chemistry while you're in a chemistry course like 119. And that is the grass, might be snow, behind the greenhouses where Wadsworth Street and University Avenue meet, or University Drive. So Wadsworth and University Drive over there behind Newton is where we meet. That way, your professor and your allies can do a head count. They need to know that you're okay and that you're not stuck in the building. And if you leave the building in some other way and you wander off to Starbucks, we don't know you're okay, and we might have to send emergency personnel looking for you, right? And that's dangerous for everybody. So it is really important to make sure that no matter how you get out of here, you do meet at our designated meeting spot so that your professor can do a head count to make sure you're okay. If your lab partner doesn't show up, let your professor know, because that's potentially a problem, so that we can make sure emergency personnel know what's going on. All right? And then only when your professor says to disperse, then you can disperse, or maybe come back in because it was a drill. So that's really important. And it's likely to happen sometime this week during one of the safety lectures, because that's when the drills tend to happen. It's also really important to make sure that if there is, something that happens in this room, that we deal with that as well. So if you have an injury of any kind, it's really important to let your professor know. I know a lot of folk are like, it's just a minor thing. I just cut myself. I just burned myself. It's fine. But we can't help you if you don't tell your professor. You will not get in trouble. Your grade will not be affected if you get hurt in this class. The only way we can help you is if you tell us, so that we can, one, help you, and two, make sure it's not happening again to you or somebody else. So again, you will not get in trouble. Your grade will not be affected if you get hurt in this class. You must tell your professor, who will then likely tell me, so I can help you, your professor can help you. I do have to let you know that all injuries in this course must be reported to university police, because they're the ones who do the accident report forms. You are not in trouble. They're just making sure that it's documented so that if there are patterns, those patterns can be dealt with, right? And if it's invisible, then how do we fix it? And so you're not in trouble. If it's a minor injury, well, then we'll deal with it. We'll grab the first aid kit. I'll show you where that is in a second. And we'll get you what you need. And then somebody will let me know that happened. And I'll call UPD. They will come in. I will let you know they're coming. They'll come in. They'll take you out for 5 minutes. They'll go, okay, what happened? How did it happen? Are you okay? And then they'll put you back in the class. It's not a big deal. But if it is a big deal, of course, we'll deal with that as necessary. Those things happen. If you're feeling faint or other issues, if you're feeling ill, come tell your professor, because people do hit the floor because of blood sugar moments or other reasons. And that's really bad if you hit your head on the way down, right? So let your professor know what's going on so that we can help you, and get you through it. So very important. Always tell your professor no matter what. If you get a paper cut, tell your professor. That is a potential injection site for a chemical. And that could be bad, especially for that second experiment where we're doing nickel chloride. We're working with nickel chloride for limiting reagent. If you have a strong nickel allergy and that gets pushed into an open wound, that could be bad. So let your professor know if you have allergies to some of the chemicals we might be using, if you know about that. Just like if you have allergies to latex, for example. Are there any questions about that process? Okay, so the first aid kit in both rooms are in the cubbies. Right up here, it's labeled first aid. And if you ever need anything, just grab what you need. Again, tell your professor, but feel free to grab what you need. If you need a Band-Aid, grab a Band-Aid. The only thing I ask about that is I need to know if you got injured in the room for the reasons we just talked about. If you were injured outside of the room and not related to chemistry, but still need a Band-Aid, grab a Band-Aid. Let me know that the Band-Aids are empty so that I can refill them. That's all I ask. I won't call UPD on an injury outside of the room, but I do want to know that we have enough resources for everybody. All right. Additionally, another one of your safety resources in the room is the SDS, the safety data sheets. They used to be called MSDS, the material safety data sheets, but since 2013, it is the SDS. In both rooms, and it is a mirror image again, in the cubbies, we do keep the SDS. The SDS are a listing of all the information that we know related to every chemical that you're going to be using in this lab, minus the unknowns. If you have questions about the unknowns, you'll want to talk to your instructor. However, it's really important for you to understand what you're looking at. So if you're not sure, or you do feel like you do need to use the SDS, do make sure you touch bases with your instructor so that they can review this process with you. Here, you also have access to online SDS through the Chem Stockroom website, which I have the shameless self-promotion on those little tabs next to you. You can take those home. And you just go to the SDS sidebar menu, you click SDS on the Stockroom website, you click Chem 119, you click the experiment, and every single chemical will have its SDS. If you'd like to know more about SDS, come talk to me or talk to your professor, and we'll be very happy to explain to you how those work. They are very useful tools. If you never take a chemistry class again but are in the laboratory sciences, I strongly suggest that you talk to us about how to use them, because I know that other disciplines may not give you the same support or understanding on how to use an SDS appropriately to keep yourself safe from various chemical hazards that are known and documented for every single one of those chemicals. It's also important to make sure that if you are bleeding for any reason, that you don't drag blood across the room and bleed across the... I have seen bleeding across the room. If you cut yourself, why would you not want to expose blood to other people? Why would you not want to expose blood to other people? Yeah. Bloodborne pathogens, absolutely. Absolutely. You may not know what you have because you haven't been tested for BPP anytime recently. I get tested every 3 months because that's something that I do. But even I might not know in that window, and you certainly don't know what your neighbor has. So it's really important not to expose yourself to other people's blood and try to minimize exposure of your blood to other people. If it's a minor wound and you cut yourself, what's the first thing you want to do? I mean, you can apply pressure to that, sure. That might be sort of first, but what's the other first thing you want to do? Tell your professor? I think that's what I heard from you, but I might have been wrong. Tell your professor. First thing you want to do, if at all possible, is tell your professor as you're putting pressure on it. That's like a simultaneous thing, right? But you don't want to put too much pressure on it if it has glass in there, right? So it's really important to tell your professor. That way your professor can start treating you as you need it, and then your LI or professor will come tell me, and we'll start working with you more. You might want to, if it's minor, you might want to wash out the wound with some water to get any glass or chemicals that might be in it. And then put some pressure on it while UPD is coming to be able to take that accident report form. And then while you're waiting, you've washed it out, then you're getting a Band-Aid or a gauze for you, right? If it's major, stay in place. We'll come to you and we'll deal with it as necessary. If there is a major wound, it is really important to make sure that we think of safety as a community effort. If somebody's bleeding heavily because they just cut themselves on a beaker that they were grabbing, right? We don't want them to walk to their professor. If you see somebody hurt, then it's also your responsibility as the first responder. I mean, not the official definition of first responder, but if you're the first person to see somebody hurt, then you are also communicating with your LI and your professor and with me. And if you're the second person to see somebody hurt, then you're also communicating with the professor, because the person communicating with the professor might be talking about the weather. You don't know, especially since we have one professor for 2 rooms. And so everybody is the second person. Don't just be that innocent bystander going, something's going on. I'm just going to focus on this. Because that person who is hurt is still hurting. And everybody's assuming somebody else has dealt with it. We don't want to be those people in the laboratory. Everybody should be part of that communication process. Don't crowd that person, but make sure that person is getting help from the people who are in authority, which would be your professor and me, or my technician, Nick, who starts soon. Any questions about that? If you have a spill, then don't try to just clean it up by yourself. Some things do not wipe up well. And acid, when you spill it and you wipe it up, you're just spreading a thin layer of acid across the desk, and it will dry clear, and the next person who puts their stuff down will start to burn. So it is very important to talk to your professor, and then your professor will help you. They might say, hey, you're going to neutralize it with the sodium bicarbonate by the sinks. They might say, hey, we need to do some other things. You also want to be very careful. These are live electrical components right in the middle of the desk. We do not want to get them wet. It's really important to talk to your professor and have your professor help you. Are there any questions about that? Okay. So, if something major happens because you weren't wearing your goggles and you got something in your eyes, I hope that never happens, and that has never happened at this institution while I've been here, because people have been wearing their goggles. I have seen people who would needed to use an eye wash if they hadn't been wearing their goggles, but people have been, which is great. But if you ever need an eye wash, I want to show you where both are in this room. Again, it's symmetrical in the other room. So the first one is going to be by the sink. Almost done. First one's going to be by the sink right here. I'm just going to move some of the stuff because it's nice and wet. And you want to press this, and you're going to turn that on. You're going to hold it on. It's actually going to stay on if you press it all the way. And you're going to stick your face into that. How long do you think you need to be in here based on the video you watched? How long do you need an eye wash if you ever need it? Yes? 15 minutes. It takes that long to osmotically, chemically, mechanically get stuff out of your eyes. But can you imagine trying to hold this up by yourself, holding your eyes open for 15 minutes, and dealing with that all by yourself? Absolutely not. Could you even see it maybe if you needed it? Probably not. So again, that's why safety is a community effort. If you see somebody hurt, bring them over here, right, while somebody's grabbing the professor, because they may not be able to see it. When you need it, you're going to be holding your eyes open. So I want everybody to do this. Go ahead and grab your eyes and hold them open. Grab your eyes and hold them open and roll them around. Roll them around. Roll your eyes at me. This is the one time you get to roll your eyes at me. Roll your eyes. All right. You want to roll your eyes for 15 minutes because that's how you get the water around it to clean things out. If you're wearing contacts, that's okay. Your contacts are going to get washed out. Don't try to pull your contacts out. The water will do it. Your eyes will not be any more hurt by wearing contacts than by not wearing contacts. Research has shown that. So it's okay to wear contacts in this room. They'll just get washed out by an eye wash if you ever need it, but hopefully you don't because you were wearing your goggles. If you need a safety shower because you got chemicals that went through things, because a big bad thing happened and your lab partner did something bad and something exploded, or a big spill or a big splash. Remember, this is not magic, it's just layer defense. Things go through, it's permeable, right? You might need a safety shower. Safety shower in both rooms next to the second eye wash is over here in the hallway. It's in the hallway of both rooms. And you'd pull, for the eye wash, this. And for the safety shower, you'd pull a single handle and water will start dumping on you. How long do you need to be in that? Same time as an eye wash. How long do you need to be in a safety shower? Not a California shower, it's 15 minutes. 15 minutes, again, to osmotically, chemically, mechanically, all that stuff. But it's kind of like showering at home. Do you shower at home with your clothes on? If you do, it's weird. If you shower in a safety shower with your gear on, it's not helping you get that stuff off of you that has gone under your gear. So, again, in this room I heard a little bit about how many of you are biology majors? How many of you are neuro majors? How many of you are biochemistry majors? Okay. How many of you are chemistry, geology, physics, education? All right. The reason why there's a differential is because bio and bioderivative, that's a joke there. Bio majors and bioderivative majors know what the human body looks like. You can help me hand out the pamphlets to everybody else because we all look the same. And to get naked, to use the safety shower appropriately, is how you use it appropriately. Because otherwise, it could hurt you worse. So if you ever need to get pulled into a safety shower, your professor or I might start stripping you, and that is why. Now, again, at this institution, we've never used one the entire time I've been here. But if I don't talk to you about how to use it, then you don't know how to use it, right? So this is not meant to scare you. We've never needed one the entire time we're here. But I want you to know how to use it. Super important. Okay. Any questions about the safety shower or the eye wash? All right. So, if there are any reasons why you might have a physical impairment, a hearing impairment, or a visual impairment that make it difficult to get down the stairs, to evacuate during an emergency, it may be important to fill out the Emergency Evacuation Assistance Form. That's going to be on the Stockroom website. There's also an example of it on the wall right over here. And I have actual paper copies on the corkboard outside of my stockroom, which Dr. Turan is going to be showing you. Fill that out. Turn that into me, and if there's ever an emergency, I will go looking for any individuals who filled that out for this time and help you get out of here safely. You can rescind it at any time, and it does expire at the end of every semester. So if you need it for multiple semesters, for multiple chemistry courses, you'd fill it out every semester. I will keep it confidential. I won't tell Dr. Turan unless you want me to. Or if you turn it into him, he'll turn it into me. Our job is to get you out. Your professor's job is to make sure that everybody's there at the end. Any questions about that? Again, that's on the Stockroom website. I believe it asks you to circle yes or no on that last question on have you been informed. You have now all been informed of the Emergency Evacuation Assistance Form, so circle yes. So I think I answered every single question on the safety quiz. Did I miss anything?
For special medical conditions, is that just your instructor?
Thank you. If you have any special medical conditions that might impact your laboratory experience in any way, it is very important to let your instructor know so that your instructor can work with you for various accommodations. Your instructor cannot help you. And I just want to caveat with that as well. You know, especially for first-year students and early students, when they come to college are like, if I use my accommodations, I'm less than. I don't want to have to bother my professor about that. I don't want to look like, I need extra things. But that's what those accommodations are there for. We have the Office of Accessibility to be there to help you have the most fully engaged academic experience you can. And if you don't use those resources, then you're not getting that full experience in a way that is meaningful to you potentially. And so we want to maximize your experience here. Do not be afraid to use those resources to maximize your laboratory experience or any other classroom experience. That's what it's there for. There is no shame in using resources as you need them. That's what we're here for. We are here to help you. We're here to help you have an amazing, engaging science experience. So use those resources. Did I miss any other questions?
The proper response to a lab fire, is that just a
Thank you. What is a proper response to a lab fire? So, if there is a fire, now we're not using Bunsen burners, but we will be using hot plates. And sometimes somebody will put a paper towel on a hot plate and go, why is it burning? Well, thermodynamics. And so if there's a lab fire, do not try to put it out yourself. Not your job, not in your pay grade. Step back, start yelling fire. Let your professor and LI know it's happening, and then they will make the decision on what to do next. They might grab a fire extinguisher, which might be problematic if they haven't been trained in the last calendar year, because New York requires fire extinguisher training every calendar year. I have been in my career for 22 years, and I have had to be trained every year for 22 years as if I didn't know what I was doing. But that is the law, and it's important to make sure we know how it's used properly. The fire extinguisher in both rooms is by the door. Don't try to use it yourself, not your job. If it's asked for, you now know where it is. If it's ever moved and you see a fire extinguisher not where it belongs, that means it was probably used. And if it was used, it means it's not good for anything else because it might be empty. And if somebody tries to use it again because somebody just put it back, it might not have what it needs. So if you ever see a fire extinguisher where it doesn't belong in any building, in any space on this campus, let your professor know, because it probably needs to be replaced. Did I miss anything else? That was 2. I missed 2 things.
You probably didn't miss it. I just didn't hear you. If you leave the lab room, what part of your PPE must you remove every time and why?
If you leave the lab room, what part of your PPE must you take off and why? And that is your gloves, because of cross-contamination. If you have dirty gloves and touch the door handle and go to the bathroom and come to the stockroom, you've just cross-contaminated all that outside space outside of this room. It's not safe. And they might be clean, but remember, clean gloves look like dirty gloves. We can't tell. And your exposure might be that one time, but my stockroom students' exposure is the entire 4 years that they work for me, and my exposure is cumulatively over years, as is your faculty members. And so they must come off. The stockroom will not help you if you're wearing gloves, not because we don't like you, but because we need to stay safe. And we'll have you come all the way back here, throw them into a lab trash, and then come on back to get help at the stockroom. Any other questions? Okay, you will be doing lab today. So you're going to be checking in briefly before you start the lab. The very top part of the paper in your packet is your equipment checklist. You're going to be making sure that everything in your drawer and on that checklist is there. There are no substitutions. This is not a restaurant. So it is really important to make sure you have everything exactly the way it says. If you're not familiar with what an item is, you have a couple of options. You can talk to your LI or your professor to ask you, is this what I think I need? You also have the Stockroom website. Again, the shameless self-promotion is right in front of you. So if you have a smartphone, pull up the Stockroom website, go to the glassware and equipment sidebar menu that's on that 3-bar sidebar menu drop-down. Go glassware equipment, Chem 119, and a picture of everything with its name will come right up. One single picture, you'll be able to see everything in your drawer. Make sure everything is there. Make sure it's not broken. If it is broken or missing, then you'll need to replace it today. Today, everything is free. After today, it's broken or missing. I'll have to say, well, your job was to do that today, and I don't know if you broke it during your lab or if you took it home with you. Don't take your chemicals or your materials home with you. They're not safe. Yeah.
There was an incident last semester that I need to give you warning. Some students actually took some chemicals out of the lab and played around with it. If I see one student do that, you're going to be out of this course. Okay? I just give you a warning. This is a serious matter. You cannot bring any chemical material out of this lab and play around with it. That's an absolute no. It happened, but we don't know which. Unfortunately, we don't know which section.
Mm-hmm.
So delays. Make sure you be responsible for making sure everything is kept, returned, or properly disposed. But I'll give you that warning.
These chemicals, some of these chemicals are dangerous. We found some nickel chloride, which is in your second experiment, was found in one of the dining halls. Nickel chloride is very hazardous. It does not belong anywhere near food. And so, as your professor was just saying, do not remove chemicals from this room. It is not safe, especially for people who have not taken these experiments and know nothing about that chemical or any of the hazards associated with it. All right. Okay. So again, you'll be making sure you have everything in the drawer. On the back of your equipment checklist is a place where you can write in where it says check in anything that you need. Come to the stockroom. Everything's free today. Again, we'll replace it, but after today, it is not. So make sure that it is all good today. Additionally, you're going to need your PPE today that we talked about, right? Because you're going to be doing an experiment. You're going to be working with glassware, which could be dirty. It's only as clean as the person left it last semester. We ask people to clean. You're going to do that at the end of the semester. But it's just like the person who does dishes, who, if you live in one of the suites, yeah, those dishes are only as clean as, that person is. And so please be aware of that as you're using these things. Again, tie your hair back if it's long before you start today, because we are using chemicals today. The other parts that's really important is if you need to drop the class for any reason, that will make me very sad. But if you do, it is important not to, one, ghost your professor, because that's just not professional. If you learn anything in college, it's about communication and professional communication, and ghosting your faculty it's like ghosting a supervisor. It leads to consequences, right? And so please don't do that to your professor. But also don't do that to me, because I need to make sure that everything's good in your drawer. And if you just walk away and wipe your hands of it, I will have to go through your materials at the end of the semester, and anything broken or missing, I will charge you for, and I will charge you for my time. So on the orange sheet, which is the laboratory safety rules, which we just talked about, and on the back of that orange sheet is the stockroom rules, which we haven't talked too much about because of lack of time since you need to do your experiment. You are subject to all those rules. Make sure you read them before you sign that contract. It's being turned in today. I must have it for you to be in this class. But one of those things is that I will charge you $20 if you ghost me. If you communicate with me, again, my email is on that shameless self-promotion or on the Stockroom website, I can check you out in 7 minutes if everything's clean. Faster even. If it's not, might take you 20, but I will work with you to make that happen on a schedule that works for both of us. If you have a medical accommodation, I'll make those accommodations. But if you ghost me, I will charge you for my time and charge you for things even if it's in your neighbor's drawer, because it's not my job to go through your neighbor's drawer. All right, so please don't do that. Any questions about that process? If you're missing PPE again and you come to class because things happened, then I will be able to replace a few things. I can offer you a lab coat for a fee. It's $5 for a disposable one. I will offer you goggles for a fee. It is $1 for you to borrow one for the day and then bring it back at the end of the day. And you can buy gloves for me. Again, I can't compete with the bookstore. I'm not allowed to. So it's 3 pair for $5. All right. I can bill you. I don't take your student card. I can bill you. It just hits your tuition at the end of the semester. All right. Any questions about any of that? It's also really important to let your instructor know if you have any medical conditions that might impact your lab experience in any way. We can't help you unless you talk to us. So make sure that you touch bases with your instructor so that your instructor can connect you to all the services available at Geneseo to make this lab experience as good and as meaningful as possible. It's also really important to let your instructor know if you find out that you happen to be pregnant, become pregnant, or are thinking about pregnancy, while you're in this lab experience. Some of the chemicals we're using can impact any of the 3 trimesters of fetal development. So it's really important for you to let your instructor know. Your instructor will touch bases with the stockroom, and I will provide you and your instructor a stack of SDS, the safety data sheets, so that you and your doctor can have a fully informed conversation about what you need to do and any modifications that they recommend as required to continue the laboratory experience. When you're thinking about the hazardous spaces of a laboratory, we want to think about how we can move beyond just the rules. And today I've talked a lot about rules because this is an introductory chemistry course, and rules are really the foundations of how to get you used to the space and used to the routines of engaging the space safely. But we want to move beyond that a little bit. And so to touch on that, we want to use the concepts called RAMP. The American Chemical Society uses a program called RAMP. And RAMP is a wonderful tool because it helps us think a little more about how to translate these rules into this space, and also how to translate the rules outside of this space in other laboratories that you might be working in other disciplines. So for RAMP, we first have to start about thinking about recognizing the hazards. Because once we recognize hazards, we can understand a little bit better that we need to be more prepared to be in the space. So, for example, recognizing the hazard that there might be hazardous chemicals in this lab. Recognizing the hazard that there might be tripping hazards in this lab. And then recognizing the hazard that there might be potential things that could happen that if we're not wearing our PPE, or potentially wearing gloves, or putting our backpacks on dirty desktops, these are all hazards that we have to recognize. And so we have to think about that from a bigger picture. Additionally, once we recognize the hazards, we have to assess the risk. Now, that's a little harder when you're not familiar with a space, but part of this laboratory experience is to get you familiarized with these chemistry spaces. Because once you recognize the hazards, you can then start to think about what are the risks associated with the hazards? What are the risks of working with hazardous chemicals if you're not wearing the right PPE that we talked to you about? What are the risks of walking in and putting all your personal stuff onto a countertop if you haven't washed it off and wiped it off first? I talk about wiping off your countertops because you're sharing the space with a whole bunch of other people in the room who are not here at the same time of you because of all the other sections. And what if they spill something? What is the risk of you putting your stuff down on that space? What is the risk of having a backpack on the ground with all of these movable chairs that are in this room? That's a tripping hazard. So you need to assess those risks once you recognize a hazard so that you can minimize the risk. Minimizing risks are part of what we're teaching you for the rules, and part of these rules that we are talking about is specifically to minimize those risks. But that's also your job too, partially to follow the rules and partially to translate that in this space and beyond this space in any other laboratory that you're in. Because once you recognize those hazards, assess the various risks associated with them, you can then start to minimize them and make them less risky by putting your backpack into the cubby like we talk about, by making sure that your PPE is on as soon as the first drawers are opened and chemicals come out, and making sure that you wipe down that station before you start working at it and putting your stuff down on it. Once you minimize the risk, you also still need to always prepare for emergencies. And the reason why is because no matter what we minimize, there's always a potential for an emergency, even so, because of the unforeseen. So, for example, what happens if the person next to you spills something and you weren't wearing your PPE? What happens if you forgot to look around while you're walking and you're carrying a chemical and you trip over something? So, thinking about the hazards, assessing the risks associated with them, minimizing the risks that you can by following the rules and understanding why those rules exist, you can prepare for those emergencies to help the unexpected so that you're not surprised by things that pop up. Now, this is also hard to do when you aren't terribly familiar with the laboratory space. But as you get to know this laboratory space better, you'll be able to plan for those things even better because you'll recognize the routines, you'll be used to these spaces, and you'll be able to really kind of just contextualize what things are supposed to look like and how things are supposed to be done in this lab versus right now when you're just getting started, everything's new. So again, to recap, the best way to think about safety in a lab is via RAMP, where you recognize the hazards, you assess the risks associated with those hazards, you then minimize any risks that you determine, and if you're not sure, you can always talk to your professor to help you with minimization of those risks, and then still prepare for emergencies. Preparing for emergencies is preparing for the unexpected, but also preparing via doing your lab report before you walk in the room, reading your protocol and reviewing it just before you start your lab again so that you don't miss something, and being aware of the people that are around you, because it is a busy room, in order to be able to anticipate what might be happening, even if it's not something that you're doing yourself. It's also really important to let us know if something is not working or broken. If you ignore it, we don't know it's not working. And so the next person who might want to use it may not be able to use it or will waste time as they're trying to figure out why it's not working. So if you do find something that isn't working, let your professor or LI know so that they'll let the stockroom know and we'll be able to fix it or replace it or get you another item immediately to keep you going with your lab. It's also really important not to work alone in this lab. If the door is unlocked for any reason and the professor or the LI isn't in the room, don't let yourself in. If something were to happen, we can't see you behind the cabinets and the lights might go off, especially because of the motion sensors. So please make sure that you always stay in the hallway until you're actively let into the lab. And additionally, for obvious reasons, smoking or vaping are not allowed in the lab or in the building, so please put those things away.